Welcome to Manufacturing Talk Radio, the only show that takes a look at the obstacles and opportunities open to small to mid-sized enterprises that manufacture here in America. Brought to you by All Metals and Forge Group, with your hosts Tim Grady and Lou Wise.
Welcome, everyone, to Manufacturing Talk Radio. We're here today on a sunny, warm Tuesday in most parts of the country, except maybe the upper Midwest. And we're looking forward to a show again on 3D printing. We're going to go into a little more information on 3D printing and how manufacturers are using it and how they can use it. Before we go into that and introduce our guests, I'd like to say hello to my co-host, Lou Weiss. How are you today, Lou?
A little chillier than you are. We're around 30, 32 degrees, but I haven't been out since dawn, so I have no idea what it's like. But thanks for asking.
So I'm sorry, I guess the cold extends to the Northeast as well.
Right.
So, Lou, what's happening in, let's go, share with our listeners what happened last week, and then I have to ask you about the news. I'm waiting with bated breath.
Well, last week, we had a last week, didn't we?
We did.
Actually, we did have a show. It was 3D printing, and, it was not 3D printing. It was 30 under 30, and we had the Thomas Net 30 under 30 Millennial winners. We had Wes Whitney from Enterprise Products and Jennifer Wolf from Masco Cabinetry, who are two dynamic millennials. And frankly, the millennials have a fairly bad rap in the public's eye, and of being lazy, spoiled, and all kinds of other bad things. I think if you listen to the show, you'll see that you would have these two people in your organization in a heartbeat. They are terrific people. They work hard, dynamic people. It's certainly a worthwhile show to listen to. That being said, regarding news, some of the news is old news, and the old news is the L.A. port issue. In spite of the fact that the mainstream media ignored it until it was over, and now they're ignoring it again now that it is sort of begun again, it seems as though that there are still slowdowns in the L.A. port. There are slowdowns on the East Coast port because of all the smart importers and exporters who diverted shipments from L.A., diverted them to the East Coast. So now the East Coast has 25 to 35% increase in traffic. It seems as though that the union has not yet voted on their new Cadillac contract. The terms of the contract are not known. And if I was them, I wouldn't want that information out either because they wouldn't get sympathy from anybody. As I said, the slowdown is still continuing. And the White House, just because they sent in a negotiator who did his job and now has left California and the slowdown continues, the White House thinks that they did their job and everything is just hunky-dory again. Well, it's not. It's not over, and they still have a mess out in Los Angeles that's probably going to take 3 to 4 months to clear up. And that's what's happening on our ports. A second item, which just happened, it's actually breaking news for Manufacturing Talk Radio. We have been invited to participate and to broadcast live from the Institute of Supply Management 100th Year Anniversary Conference in Phoenix, Arizona, May 3rd, 4th, and 5th. And we'll be interviewing Tom Derry, CEO of the Institute of Supply Management, plus many others. Last year we were there, and we actually did about 23 interviews. Guests, people from ISM, and the co-host of that event was Thomas Net. So we're all excited about that, and we like taking the show on the road and shaking it up a little bit. Tim?
And let me introduce our two guests. We're going to spend some time today with Terry Wohlers, who's president of Wohlers Associates. And he is a consultant in the industry. Most of his consulting over the most recent years, and Terry, you're going to correct me if I'm wrong, has been with institutional investors that represent mutual funds and hedge funds. And at the bottom of the hour, Terry has another commitment, so we're going to let him go. We wanted to keep him for 45 minutes, but we haven't tintillated him enough yet. And then we're going to talk with Rick Lucas, who's the Chief Technology Officer at ExOne. Terry, I'm going to let you tell the audience a bit about Wohlers Associates, because no one can tell it quite as well as the president. How you doing, Terry?
Great, Tim. Thanks for the introduction, and you're right. We do some work with institutional investors and the investment community at large. However, our primary focus really is on industrial users of 3D printing and also additive manufacturing, terms that are being used interchangeably. And we work with a wide variety of other organizations too, government agencies around the world, and we've done some work in Washington and various other organizations. And really, we've never had so much fun. This is a great time to be in this technology that we refer to as 3D printing, something that's been around for more than 25 years. A lot of people don't know that, so it's a great time to be a part of it.
And Terry, what's happening in the recent and future 3D printing industry in terms of growth?
Well, growth has been strong. We've seen growth of 1/3, so about 32% on average for the last 3 years, not 2014, but 11, 12, and 13. So average growth of 32%. So if you can imagine a multi-billion-dollar industry growing by 1/3 every year. We haven't done the numbers yet for 2014, but we expect it'll be at least as strong as the previous 3. And then the past 25 years through 2013, we saw growth of 27% on average. And I would challenge anybody to name another industry that's been around for 25 years that has seen growth of 27% on average for every year. So it's been a very sound, very strong industry for a long time, but now it's really gaining traction like we haven't seen it in the past. All the investment that's going on, it seems that not everybody, but almost everybody wants to get into it in some way. It's really, it's almost, almost daily. We receive phone calls and inquiries, and people you bump into, they're exploring ways in which they can somehow tap into this.
And Terry, what types of companies are putting this 3D technology to work for them?
Well, historically, we've seen the major OEMs in automotive, aerospace, the medical industry, consumer products. They've been the early adopters, even as early as the late 80s and early 1990s. And they continue to use the technology for prototyping, for jigs, fixtures, other types of tooling. But the next frontier, and what's really exciting to us, is the use of the technology for the production of parts that are going into final product. We've seen growth like never before in that area. And so now more than 35% of all of the revenue generated in this industry is tied to parts that are going into final products, predominantly from the medical and dental industries, as well as aerospace, and some consumer products too, some high-end consumer products. The jewelry industry, they've been using this technology for both custom and limited edition type products, and in a range of other applications as well.
Well, let me just flip this over to Rick Lucas, who's Chief Technology Officer at ExOne. And Rick, I'm going to have you share with our listeners what ExOne is and what it does, because I know you're involved in both the equipment itself and the service of actually printing parts. Rick, how are you?
Doing quite well, thank you. Pleasure to be here. ExOne is historically been an industrial machine company. Prior to 3D printing, there were other technology, machine technology that ExOne was involved with, and And more recently, ExOne's been is pretty much totally committed to the binder jetting, 3D printing technology. There's a variety of ways of making parts with 3D technologies, and Terry's got done quite a bit in terms of evaluating the different types of technologies. Our particular technology is binder jetting, and it's and I'll probably talk more about that later on, about specifics of how that works. But
okay.
ExOne as a company, I'm sorry.
Oh, that's fine. You want to get into that later? That's great. But you also now you make production printers and prototype printers and R&D printers. Is that right?
Yes, we do. We have a number of printer technologies that we develop, from everything from prototyping to high-end printers, that very large printers that make actual sand molds and cores that are being used in production all over the world. We also make prototype printers for doing general R&D and research that's used by universities as well as OEM research departments. And as you mentioned, we generally are looking at not just the printing, but what it takes to get a complete part to work in the application. So in order to do that, we actually have what we call production service centers, where we actually not just sell printers, but we actually use our printers to make parts for people. And these centers utilize the machines that we make. And one of the obviously big advantages of that is that we see firsthand what our customers are seeing in terms of our printers and what it takes to get our printers to make parts that can be used in real applications.
Terry, what are some of the exciting applications that you're running across? Because we're beginning to see more of these pieces and parts that can be produced, and everybody's very curious. What are the applications that you're seeing in the technology, Terry?
Well, they're all over the place. It's from printing living tissue, which is still mostly in R&D, but it's starting to make its way out of R&D. From that to food printing to figurines to home and office accessories. Those are all interesting applications. We're, like I said before, more focused on the industrial application. So I'm holding a titanium cabin bracket for an Airbus A350, and this is a design that holds the interior of the interior shell of the aircraft to the body of the frame of the aircraft, and it's a very complex part, very important part. It's a structural part in the sense that if it fails, it's not good. I wouldn't want to be on the plane if it were to fail. And what's interesting about this is it uses about half the material and weight of a conventionally made bracket that you would machine, CNC mill out of a billet of titanium. And so you have less weight, which is good, and less material, which is also good, because titanium is expensive and fuel is expensive as well. And so they used a method of topology optimization to optimize the strength to weight ratio, really letting mathematics decide where to put the material to optimize the strength and weight. And so it's they call it a bionic part, and so it is inspired partly by our human nature, by say bamboo, for example, and it almost looks like something you could grow. In fact, in some sense, you did grow this. It was growing layer by layer from bottom to top. And so it's those kinds of applications where you can save incredible amounts of material and weight, and then also consolidate many parts. This part in the earlier conventional version of it was multiple pieces that were assembled. This is just one part. So there's many benefits to rethinking the design of a part or assembly and then building it in this new way.
Yesterday, they had on CNN, they had a special program called the Moonshot of the 5 Moonshots of the 21st Century, picking up on Kennedy's moonshot program of the last century. And one of the moonshot projects is 3D printing. And they had a whole segment on there, and I highly recommend anybody who is interested in 3D printing try and find that particular program on television or Netflix or DVR or what have you. What they were mainly talking about was medical, and they actually showed you the manufacturer of an ear, and it took about 5 minutes to manufacture an ear. They talked about a heart, that in 5 years from now they will have produced a heart from actual tissue from the patient, and will be able to produce a heart in the surgical ward while the patient is waiting for a heart, that they'll be building it alongside inside the printer. So it is pretty exciting, and there's some really dynamic, Star Trek type events and technology that is coming out of all of this. Rick, tell us a little bit about that kind of manufacturing, being that you're from the printer side.
Sure. As you pointed out, one of the really neat things about 3D printing is you're able to build parts bit by bit, even though it's generally in layers. The way we glue parts together or build parts, it's literally it's powder particles at a time. And in nature, nature has shown that organic type structures are more efficient than traditionally, where you have beam type construction. If you have an engineer design something, typically it looks more like beams and panels, and just because of the way things are manufactured. You take that restraint away, and now all of a sudden, where I have the freedom to build whatever shape that I want, and as Terry pointed out, with this idea of topology optimization, you can actually design a part that's really, it's got a volumetric constraint, but in terms of the shape or geometry or even the small structure of that part is really not constrained in any way. And that allows you to do what nature's been doing, build structures that are extremely complex. And that is one of the beautiful things about 3D printing. It really is challenging our manufacturing sector or the design engineers themselves, because they don't have this constraint any longer. And so that is very exciting, at least from our standpoint. We have a number of customers that one of the service side of our businesses, we actually provide parts, and consumers and I'll say businesses can go online, order parts, design the parts themselves, and I'll go back to our production area, and frequently I'll see things that just, wow, that's a great idea. And it's actually pushing the creativity of engineers and even people now to think about what can I now do. I'm no longer constrained by these conventional methods of manufacturing, and so it's really exciting to see that happening as well, that transition.
Just for clarity's sake for our listeners, and when I started getting into the concept of 3D printing, I thought of it in terms of a printing press or a photostat machine or what have you. But as being a metals person coming from the metals industry, and actually seeing this past weekend on television, that I don't see it quite as a printing device, but I see it more as an extrusion machine. Could you give us some insight on that, so that the folks at home don't see it as a printing press that's printing out body parts?
Sure, I can take that, and Rick, if you want to fill in, there's 7 basic processes, umbrella processes. One is material extrusion, where you are extruding a liquid plastic, and then that hardens when it becomes hits a certain temperature, and so that is an extrusion type process. But there are many others, like the ExOne binder jetting process, where you're inkjet printing a binder material onto a powder, and so that's a second. And then there's also a laser. Well, it doesn't have to be a laser powder bed fusion process, typically using a laser, but it can be electron beam or another source, energy source that heats and fuses the powder, and that's a popular. Those three processes are among the most popular. There are four others, but so there are many different types. But what they all have in common is they're taking a 3D model, a fully closed, watertight, three-dimensional computer model of something, some object. It slices it up and then it prints each slice layer by layer, and that's why you can take something as complex as a human skull or pretty much anything, slice it up digitally, and then print each layer on top of another, and then you come up with these shapes. And so, Rick, jump in if I miss something here.
No, you're absolutely right, Terry. I'll just add the extrusion technology that's real common in the plastics area. You may recall that everyone's used the old glue gun. Very right. Similar, where you're literally just building up the shape. And I'll say early on that was basically the initial technology. That concept is kind of what started a lot of this 3D printing ideas. But as Terry pointed out, since then, obviously, when you start looking at other materials other than polymers or plastics, where you're sintering or fusing metal or even ceramic-like materials, then there's other technologies that are better suited for those types of materials. But certainly one of the common methods at least on the plastic printers is something that would remind you of a glue gun or an extrusion type process.
And that's by far the most popular process, too. If you look at these low-cost desktop versions that sell from the lowest price one we've seen is $300, but they're all over the place. And we think more than 300 brands now of those 3D printers. And the reason those came about and so rapidly in recent years is because the basic patents, the diffuse deposition modeling, the FDM patents from Stratasys expired, and so companies and individuals were allowed to copy those designs and not everything, but at least the claims and the patents. They were it's now in the public domain. So now you see them, they're everywhere. We're just they're so inexpensive. What's great is that schools and other types of educational institutions are buying these, not just one or two, but equipping entire laboratories with these low-cost 3D printers, which is great.
Terry, you've dispelled one of the myths that I had about 3D printing, and that is that it could not be used in a production environment. But you've already talked about a bracket that goes in an Airbus airplane for the airframe. That's clearly a production part. What other myths and misconceptions exist about 3D printing?
Yeah, well, just to expand on that, Airbus has tens of thousands of parts on their aircraft. Boeing has over 100,000 parts on their different, both commercial and military aircraft. More than 100,000 hip implants made in solid titanium have been produced. More than 20,000 copings are made every day. A coping is a dental coping to make a crown or a bridge for a tooth restoration. More than 20,000 of those are produced every day of the week. Countless jewelry is made that consumers are buying. So there's a lot of product that's being produced in this way that most people don't know about, and quite honestly probably don't even care, because most average consumers really don't care all that much, unfortunately, about manufacturing, although 3D printing is bringing to light a new way to produce things that is more accessible and can be decentralized and can be used by people who maybe aren't as highly skilled and trained as perhaps someone working in a conventional machine shop. But Lou, I'm sorry, I didn't really answer your question. If you could restate it, I'd appreciate it.
It really was about the myths and misconceptions about 3D printing.
Right. Okay, so one is the misconception that a heart will be printed in 5 years. Forgive me, Lube. I had to. So we are often led to believe that these things will come about soon. I spoke with the leading, arguably the leading expert on the subject of tissue engineering and regenerative medicine by 3D printing. His name is Dr. Anthony Atella at Wake Forest Medical Center, and he explained. I asked him, because he's done a lot. He has a team of 400 researchers and physicians, and so he really knows this stuff. He's done a lot of work in this area, and one misconception is that we'll be printing human body parts in a few years. We have seen a lot of work, and there's been a lot of investment in this area, but I asked him, will we be able to print a human organ within our lifetime? And he would not say. He could not answer it. I don't think he really knows. And I don't think anybody knows. But I doubt very much it'll be 5 years. Maybe within 10 years we'll be printing partial body parts, maybe part of a finger, maybe part of a kidney, or some other liver, whatever. But we still have a lot of work to do before we get to the point where we're producing an entire human organ. A lot of other misconceptions. One is that these machines are very, very fast. It can take, for some of these industrial machines, more than 40 hours for production. In fact, it can take even that long just to cool down the bed of parts inside the powder. If you have one of these large-scale machines that are filled with powder, polymer, and you have large parts in them, it can take 20 to 40 hours for them to cool down before you can pull the parts out of the powder. If you try to accelerate the cooling, the parts will warp. And so, these processes are fast compared to building small quantities of parts using conventional methods like molds and dies and so forth, but they aren't as fast as we're led to believe. Another misconception is that they're very easy to use. They're push button, and that's the furthest from the truth. There's a lot of data preparation. The way you orient parts, do you lay them down, do you stand them up? You have support material that needs to be considered. That has to be removed. In the case of metal parts, you have metal against metal. In other words, the metal parts are attached to a build plate with metal, and you have to remove them from the build plate, which all usually requires EDM or a bandsaw or something like that. Then you have to remove the support structures from the parts, and so there's a lot of steps. So they are not easy to use. I talked for more than an hour at a conference recently just on the misconceptions of this technology. So I could go on. So you need to shut me off here.
That's okay. I guess it's really useful in R&D and rapid prototyping.
That's where it excels. I mean, the value of being able to get a part in your hands, a new design, a proposed design, or a wide range of designs in your hands quickly is incredibly valuable. To be able to focus on the best design and then iterate and make it as good as it can possibly be, and to fix all the problems and errors early in the design cycle when they're least expensive versus waiting until you get into the tooling or worse, into the manufacturing stage, finding an error and then having to address that. It's better, and that's what this technology allows you to do, is to design, iterate, get something in your hands, test it for form, fit, and function, and then make the design as good as it can possibly be.
Before we break for a commercial, Terry, and I know you have to leave unless you'd like to stay on for a bit, we'd like to get your website information so people can reach out and make contact with you.
Sure. The fastest by far is to Google our last name. It's Wohlers, Wohlers. That's company's Wohlers Associates. We've been doing an industry report for 19 years. We're currently working on the 20th annual edition, and so you can read about that on the web as well. So I really appreciate the opportunity to be a part of this today.
Thank you for joining us. Jim?
We enjoyed having you, Terry. We will invite you back in the future because we're going to stay on top of this subject. We think it's important for the manufacturing industry to really begin to learn how to use it. We're going to take a quick commercial break, and we will be right back with Manufacturing Talk Radio.
Manufacturing Talk Radio will be right back.
American Crane and Equipment Corporation in Douglasville, Pennsylvania is a leader in specialized cranes, hoists, and material handling equipment for industries including aerospace, nuclear, oil and gas, transit, construction, and waste handling. Call 877-877-6778 or visit AmericanCrane.com. That's AmericanCrane.com or 877-877-6778.
How do you keep your business humming? Where do you go when you're looking for quality suppliers of new equipment, components, MRO supplies, repair services, or even raw materials? 30 years ago, you would have turned to the Thomas Register. Today, those big green books are better than ever at thomasnet.com, industry's leading platform for product sourcing and supplier discovery. You can easily find that local machine shop, national distributor, OEM, or any supplier having the right quality certification, fast and free. You can even get to specific products, components, or downloadable 3D CAD drawings simply by entering specifications or part numbers. There's a reason thomasnet.com has become the go-to supplier discovery tool for procurement professionals and engineers. There's simply no other resource like it, and it's all free. Go to thomasnet.com today and see how top-notch supplier discovery doesn't have to put a dent into your bottom line.
All Metals and Forge Group is an ISO 9001 AS and EN 9100 manufacturer of open die forgings and seamless rolled rings in alloy, carbon, stainless and tool steels, aluminum, copper, titanium, and nickel alloys. Visit us at steelforge.com or call 800-600-9290.
Welcome back to Manufacturing Talk Radio.
Welcome back to Manufacturing Talk Radio at mfgtalkradio.com. You can follow us on Twitter at MFG Talk Radio. We're here discussing 3D printing. Is it the key to making manufacturing in America grow again? With Rick Lucas, who's Chief Technology Officer at ExOne. Rick, I'd like to talk to you a little bit about ExOne and some of the things we touched on in the first half hour of the show. In terms of your customers calling in and saying, hey, can you print a part for us, print on demand? How do you serve your customers in that area, Rick?
Sure. We have a couple different business models. One is, as you pointed out, simply people can call us direct. And in that case, generally they'll have an idea of what they want in terms of a part. We generally need some kind of drawing, or we prefer to have a 3D model of the part that they want made. We also have third parties that do this as well. There's a number of companies that probably people are familiar with, Shapeways.com, Amazon's even. You'll see that a lot of these sites are coming up now that are selling 3D printed parts, and so we'll work through them as well. But in both cases, obviously we have to work with the customer and get a sense of what the part looks like. Generally, that's a 3D model, and there's a number of programs being developed that assist consumers and companies with making these models. As you might expect, for large companies, OEMs and such, they have parametric modeling software programs like SolidWorks and Autodesk, Pro Engineer, and a number of other programs, and the engineers are familiar with making these models. On the consumer side, that's obviously a lot of these programs don't exist, and there's a number of companies out there that who are trying to provide these programs for consumers that are more user-friendly and easy to create these models. But once we have that, then simply it's more of, okay, what's the form, fit, function of the part? Is there a certain type of material that you need? Generally, we are producing metal parts. and that's really tied to binder. Our binder jetting technology is very well suited for metal parts, or I'll say bonded parts. And so once we have the file,
Let's talk a little bit about that binder jetting, because that's a term I haven't heard before. That's something you folks bring to the table. What is binder jetting technology?
Yeah, I mean, simply, probably the most familiar process to people would be your inkjet printer at home, where you have a piece of paper, and in that case, you're jetting binder onto the paper. Mm-hmm. In our case, what we're simply doing is we're dispensing, instead of ink, we're dispensing binder onto a powder bed. And so you literally, as we alluded to in the previous hour, when you build these parts layer by layer by layer. So what you would do is, once you have your model, is usually that with software it gets sliced into a bunch of individual slices. And that creates this cross-sectional views. And so what we do is we spread a layer of powder, and then binder gets jetted on, similar to what you would be able to remind you of printing onto a piece of paper. And then you would put another thin layer of powder, and then jet more binder, and you do that until you build the part. One of the advantages of this technology is you're really not limited on the material side, because as long as you can get the material in a powdered form, and you have a suitable binder that will glue that particular powder, you can really build any type of part. And the advantage of binder jetting is the speed and size of parts that you can do with this technology. I mean, there's a lot of pluses and minuses with the different technologies, and I would just encourage our listeners to really take a look at the different technologies that are out there. And what drives the selection of probably the technology you're interested in would be obviously the price you're willing to pay for your part, the type of material that you need for your application, and then certainly the performance. What type of performance do you need out of that part? But one of the advantages of binder jetting is it's fast. It can be done quickly. As you've seen people print, your printers print on a piece of paper, that can be quite fast. And I say fast, as Terry pointed out earlier, 3D printing, fast is a relative term, but in comparison with other, I'll say, 3D printing technologies, binder jetting is generally more cost-effective and the most cost-effective and the fastest printing method of the different technologies. One of the disadvantages is that you have a glued product now. So it reminds you of just, you can see the shape of the part, but now I have to get that into a solid form. So if people are familiar with powder injection molding or metal injection molding industry, where you have glued powder, very similar. This is really a powder metallurgy printing technology. So you have to center that afterwards, and so you take that green form, and then it goes through a process where you apply heat to get that metal to center. Now there are obviously that particular technology area has been around for a very, very long time, so it's a very well understood process. And again, one of the advantages of binder jetting is it's a powder metallurgy process. So it's most manufacturers and OEMs that are familiar with powder metallurgy are very comfortable with this particular technology, and have a lot of the equipment and processes already in place. We in our factory here, we literally produce thousands of parts quite frequently. You go in the back and you'll see literally hundreds of thousands of parts that are going out. And what we've had to do there is go to more of a continuous furnace. You can process these powders in either a vacuum furnace or a continuous furnace. Would remind you of like a pizza oven, where you're literally setting your parts on a conveyor, and then you're taking the parts off on the back end of the conveyor. So again, a key for binder jetting is obviously it's fast. You can do very large parts, and then the flexibility with materials. You really have a number of material options there. And when you think about gluing powder together, that's a fairly simple process. So as long as you've got the product in powder form and you've got a binder that'll stick it together, then generally our process will work for almost any material.
Rick, and you've been mentioning all types of materials from plastics to metals to titanium and so on. I haven't heard anybody talk about glass. Is glass a product that could be produced in the same method?
Yeah, in fact, we've actually produced glass. Simply, again, you have to have the glass in a powdered form, but it's simply glued together and similar to how you would fire glass and more of a kiln type of a process. So glass and ceramics are two materials that we actually print a lot of. Related to that, we also, probably the number one material that we print above more than anything else is sand. If folks that are familiar with the casting industry, which is a very large industry, there's almost everything that we that you use in your day-to-day life. There's cast parts, and those are everything from your automobiles to about any type of transportation vehicle that you get into. It has cast parts in it, and the way those are made are with sand molds and cores. And we do a lot of printing of the molds and cores. One of the big advantages over conventional methods is that generally you have used to be the old wood patterns are still quite common, where they'll make these patterns from wood or they'll print them out of plastic of some kind, and then they mold the sand around them. Where we simply, with our printers, print the sand directly. And we have very large machines that'll do that. We actually recently announced a brand new machine called the ExOne machine that prints in production, in a production line. So the vision of that machine is literally it would be embedded into an automotive or high volume application, where you literally are printing these molds out, and then they're going down, and then you're casting metal into them. So obviously sand, glass, ceramics, these are all materials that are very well suited for the binder jetting technology.
In terms of size, you say that you can produce very large parts. What about the thickness, a wall thickness of a particular part? What's the thinnest that typically you can go?
Yeah, generally, what limits how thin you can go is your powder itself, and powders vary in size. The smallest powder that we print is down to about 10 micron, which is quite small. Generally, our layer thicknesses are about 100 micron, and you're generally limited to, in terms of wall thicknesses, a couple hundred micron is quite common. Is not a problem. I mean, obviously it depends on how long the wall thickness, how long it is, how it connects to certain features of the part. But it's not difficult to do, a couple hundred micron wall thicknesses on the directly printed side. Now printing it is one thing. The most difficult thing with binder jetting is maintaining the geometry after it goes through its centering step. So as you imagine, I've got this glued metal powder, and now I've got these features and maybe a thin wall of some kind, and now it has to go into a furnace. And as that metal heats up and begins centering, the challenge is controlling that in such a way where it doesn't distort or it doesn't slump, and so we've actually spend as much time working on what happens after it comes out of the printer, as it is actually developing the printing technology to print the materials. And of course, as the parts get larger and larger, that challenge becomes greater and greater.
Well, let me ask you a question about the glued powders. Without necessarily going into a furnace to harden the material, can you take the part that you've now glued the powder, and can you actually coat that or chrome it or paint it or whatever kind of surface condition, and will it preserve the integrity of the part?
Yeah, without doing centering, the main use for that product is generally some kind of tooling or mold of some kind. I talked about sand molds and cores for casting, and coating that is actually a quite common thing to do. There's obviously it improves the surface finish. It can provide benefits in terms of chemistry, as if you're pouring hot metal against it. And certainly on the directly printed and after we center parts, all the conventional methods that you would use with conventional manufacturing in terms of plating, whether that be with gold or nickel or patinas, we provide those as well. So the parts that we make in our service centers, we offer not just the parts themselves, but we also provide surfacing options in terms of surface finish and as well as different plating options. Particularly, this is of great interest in the art area of art where they're looking for something more attractive. But even on the manufacturing side, there's coatings that related to durability and maybe corrosion resistance, and we utilize those coatings as well.
Rick, I'm on your website, which for our listeners is ExOne, ExOne.com, and I'm in your resources section. I'm just looking at materials, and beyond silica sand, I see 420 stainless steel with a bronze matrix, a 316 stainless steel with a bronze matrix, and regular 316 stainless, 17.4 stainless, which is, I know Lou's company's had a lot of experience with 17.4, alloy 625, alloy 718. These are all materials that our sponsor, All Metals and Forge Group, uses for forged parts. In terms of large forged parts, are any of the printers capable of producing large parts that would rival a forging in terms of physical properties or chemistries, Rick?
Certainly, in terms of properties, we've been able to demonstrate on small scale. When I say small scale, we have a number of different print platforms. Our MFlex, for example, will print parts up to 10 by 10 by 16 inches. That's a nominal size. The largest metal machine that we produce does parts 16 by 16 by 30. And in those cases, we've got like you mentioned the matrix materials. Those the 420 with the bronze and 316 with the bronze infiltrant. Those are not going to be certainly not have the properties of a forged 420 or 316. Those materials are, however, very effective in applications where there's high erosion. I can tell you in like the oil and gas industry where there's certain applications where erosion is a major problem. Matrix materials can be very effective, in fact, more effective than some of the steel alloys that are, say, generally used in those applications. The Inconel 625, the solid single alloy material there, it's not currently the properties are not quite as good as forged, but they're actually still quite good. And certainly we're working on improving those. This is one of the challenges when you talk about 3D printing. when people see, okay, that you're printing ink in L625, people naturally assume, okay, I can print big parts and I can have the same properties as wrought, and there's no other issues that I have to be concerned about. And this is something I think we have to be careful with, is because there's a lot of work that has to be done to qualify these materials in a given application. Everything from, I'll say, different types of mechanical testing to validate them, corrosion testing. I will tell you that we are making ink in L625. We're able to make that at 100% density. It has great material properties. Would it replace a large forged part? Right now, mainly we are focused on, I'll say, smaller parts. And I say smaller, something that's less than, let's say, 8 inches by 8 inches by 8. A big part it'll be some time before we're able to make really large parts with that material. And really, what limits that is more of the slumping distortion that I alluded to earlier when I go into a furnace and being able to maintain its shape. But certainly material properties is something very important to us, and that's why you also notice on our website we talk about qualified materials and what we call printable materials. And what we're differentiating there, if it's qualified material, we have a formal data sheet that will tell you what you can expect in terms of material properties from that alloy. And generally those materials we offer in one of our service centers. You could actually come to ExOne and buy that product with that material and have some assurance about what you could expect in terms of material properties. What we call printable materials. Yes, go ahead.
Yeah, I was going to ask, are you familiar with AMS specifications?
Yes, we are.
And
in fact,
what I was going to ask was, can you produce to those specifications?
In some cases, yes. I mean, we certainly all the testing that's done on these materials are done to ASTM standards, and certain alloys are very well suited for this technology. In fact, you can basically get the equivalent properties. In other alloys, we cannot at this point in time, and so there's more work that's got to be done. I also just want to mention that historically ExOne has primarily worked on what we call these matrix materials, the 420 stainless infiltrated with bronze and the 316 infiltrated with bronze. It's only in the last 2 years where we've really made a concerted effort to go after some of these more common alloys and do full density. And so a lot of this is just, it's not really a limitation of the technology as much as it is just spending the time to go through the development work. So printing enough samples up and enough parts up to get all the data that you need to say this is an ASM, is qualified to this ASM standard. There's just the work there just still has to be done, but certainly we've been able to show that we get good properties. We can do full density, single alloy, common alloy materials with the technology and get good properties.
Rick, one of the things that we've been talking about on the show, kind of a theme that runs through the show, is making manufacturing cool, or at least trying to get the point across to the millennials that manufacturing has got some cool applications. And certainly this is a really cool application. What is ExOne doing with education with colleges and universities?
Yeah, we actually have a group within ExOne called XTech, and we have a number of programs where we go out and we're partnering with universities. We certainly have provide tours to educational groups whenever there's an interest to come through and see the technology. But we have a very aggressive program in reaching out to students and educating them about our technology. We have a a new what we call design center that's being created right now that really is going to be educating and training people on. We've talked about design for additive manufacturing, where we get engineers and young people thinking about being creative on the design side, so you can create these new optimized designs, and we certainly are reaching out to students and colleges and we'll be working with them as we develop this new center here at ExOne. But reaching out to the young people and getting them familiar with our technology with 3D printing is certainly a priority for us. There's a group out there, I'm familiar with the America Makes, is a government-sponsored group, and which has obviously been a champion in this area in terms of getting the word out about 3D printing, and we are very active within America Makes, and certainly support what they're trying to do, and obviously it's a major objective for us as well as a company to reach out to students and get them familiar with this technology so that they can use it.
Rick, are you familiar with Manufacturing Day? It's held the first Friday in October, where thousands of companies open up their company for tours to show young people, students, teachers, and so on, what's going on in manufacturing. And Manufacturing Talk Radio has been a sponsor of that program as well. And we actually have live broadcasts with the 3 partner associations that are affiliated with this. And I would certainly think that this would be an outstanding way to get your message out. It's called and the website is manufacturingday.com. And if you'd like to hear more about it from us, I'd be happy to talk to you off the air about it.
Sure, no, that'd be great. I think actually we participated last year, and very great program, and I think it's great what you're trying to do there.
It's a fabulous program, and they actually had over 100,000 people that visited manufacturing plants in all 50 states. So it was quite a success last year, and I think last year was the 3rd year that they did it. And President Obama actually made it an official day of recognition for manufacturing. So.
Now, Rick, we've got about a minute and a half before we begin to wrap up the show. What's the most either oddball or strange or interesting application that's come across ExOne that you guys have had to tackle?
Wow, probably the most interesting ones I can't talk about. I'll just say there's a lot of problems we have solved for manufacturers that, and we always joke about this at ExOne. The most interesting stories and the coolest things that we've done, generally we're not allowed to talk about. But it just goes to show you the value of a large number of OEMs out there that see the value in the technology for solving some of these challenging problems. Outside of that, I will say that we have a lot in the consumer business. We have a lot of unique designs come through, and a lot of times you know what the parts are, and a lot of times you don't. It's obvious people are creating these solutions, and their 3D printing enables them to go out and do some prototyping, and they're testing these parts on everything from probably bicycles to who knows what else. But it's really I can't put my finger on one single thing, but I will tell you that I see very unique things come through here quite frequently, all the time.
Well, Rick, this has certainly been enlightening and terrifically interesting, and you and I will have a conversation once we're off air. I'd just like to mention to our listeners that in about 1 hour, this show, if you didn't hear the whole show, will be a podcast on mfgtalkradio.com. And we're going to be wrapping up in a minute, so I'll flip this back to Tim.
Well, thank you, everyone, for listening. We've enjoyed having Terry Wohlers on from Wohlers Associates and Rick Lucas on from ExOne. Certainly, ExOne's a resource for manufacturers. That wraps us up for Manufacturing Talk Radio today, and we'll be back again with you next week. Thank you for listening.
Thanks for joining us on Manufacturing Talk Radio. You can hear our next broadcast each Tuesday at 1 p.m. Eastern Standard Time at mfgtalkradio.com.